In a geocoding operation, address data contained in a table or a text file are mapped against the street network dataset. The street network needs to have attribute fields for address ranges on the left and right side of each road segment. Geocoding has many applications, including mapping the customer base for a store, members of an organization, public health records, incidents of crime, etc. Once mapped, the points can be used to generate density surfaces and can be tied to parcels of land. This can be important in a cadastral information system. So here I've got QGIS Desktop open with the streets loaded for Bernalillo County, New Mexico. And let's look at the attribute table. I'm going to right click on this and open up the attribute table. And you'll see that in addition to fields you might expect like street name, there's also this series of fields left low, left high, right low, right high. These attribute fields hold the address range for each road segment, and these are necessary in a geocoding operation. The software is basically going to extrapolate the position of the address based on these address ranges for each road segment, and it'll know which side of the road to place the point on, the odd side or the even side. So I'll go ahead and close this. And next I'll add the address table. So I'll click the Add Vector Data button and click Browse. I'm going to change my format to CSV and select Address as CSV and Open. And let's right click on this table and open it to look at this data. It's always good to familiarize yourself with your data before you begin to work with it. So this file has an address column with the full address, with the street number, the street, and the quadrant of the city. And then there's some other fields with different components of that address parsed out. So there's a column with just the street number, a column with just the street, a column with just the quadrant of the city, and then columns for the city, state, and country. The tool we're going to be using requires separate fields for the address number and the street. So now that we're familiar with the data, we're going to enable a plugin that we're going to use to geocode these street addresses. So I'm going to go to the Plugins menu, Manage and Install Plugins. And the plugin we're looking for is called MMQGIS. And I already have it installed. If this needs to be installed on your system, simply go to the All tab and type in MMQ to start searching for this plugin. Select it and install it. Here I just need to check the box to enable it, and I'll click Close. And when it's installed, MMQGIS becomes its own menu. So to start, I'm going to click the MMQGIS menu. There's a lot of other tools in here that you might want to familiarize yourself with, but we're going to be using the Geocode suite of tools, and we're going to start with Geocode from a street layer. So first, I just need to browse to the address table. Go into my Lab 6 data file and select addresses.csv. Here, QGIS is already picking up on the correct columns for the street name field and the number field. If they're named logically, that usually is the case. If they're not, you can always just click the drop down to select the correct field. The street layer is going to be streets. And now we have to set the fields for the street layer. Street name is the correct field for street name attribute. And we're going to leave the from X, from Y, 2X, and 2Y as the defaults. Street line start, street line end, street line start, street line end. If you have actual coordinate values for the beginning and ending of each street arc, you could use those fields in place of this. Next, we have to pick the fields that contain the address ranges. So the left from number will be left low, the left to number, left high, right from is right low, and right to, right high. We don't have any zip code data involved in this. Finally, we just have to pick an output shapefile. I'll navigate to my Lab 6 data folder, and I'll call the output street geocode.shape. So one thing about geocoding operations is that they rarely have 100% success. The street names in the street shapefile must match the street names in the CSV address file exactly in order to match. And so there's going to be a lot of cases where you'll have typos or other characters that do not match. So the tool will save out a list of unmatched records. So here I'll click Browse here to specify what I want that to be called. And I'll again go into my Lab 6 data folder, and I'll call this street not found.csv. And this gives you a way to investigate the records at the end of the geocoding operation that didn't match and try to figure out why. Another setting we can incorporate is the building setback. Street layers are usually called street centerline layers, meaning that the street arc is actually geometric center of the street. So on a large boulevard with a median, the line actually will be running down the median of the road. So the setback allows you to move the points off the street line to better represent where the actual buildings lie. So here we're going to set this at 20 map units. Our map units are feet, so this will be 20 feet off the center line, which for the average road will put the point roughly where the building is. So now that we've got the form completed, click OK to run. And this will take several minutes to process. Okay, so the operation finishes, and down here at the lower left, we see that 199 of the 203 addresses geocoded from 41,825 street records. So to start investigating the quality of this operation and how well it worked, first, well, let me go ahead and before I do that, make these points a little bigger and brighter so that they show up on the video a little better. Make them big red points. And I'm going to right click on the layer and choose zoom to layer so I can see where they all fall. So it doesn't look like there's any points outside the city limits, which is good. Let's take a look at the attributes for the new layer. One thing you'll notice is that all the attributes from the CSV address table will be brought into the shapefile. So we have facility type, the name of the facility, the address, and all the other attributes that come with it. It's also computed the longitude and latitude, which in this case are actually the X and Y coordinates. This is in State Plane, New Mexico Central. So these are state plane coordinates, not actually longitude and latitude. So I'll click close on this. I also want to just inspect the points a little bit. So I'm going to zoom into a cluster of address points. And I'm going to use the identify tool. I have my geocoded address shapefile selected. I'm going to click on one of these points and see that this is on 6th Street Northwest. Select my streets and click on this same street just to spot check the data and make sure that it's doing what we expected it to. So that is in fact 6th Street, so that looks good. And you can see that the points are also offset by 20 feet off the line. And down here, this is an example of where the points are actually offset on opposite sides of the road because it does know the left and right side of the street. So let's investigate these. This is on Broadway Boulevard, 1500 and 1501 Broadway respectively. And if we click the streets layer, we see that in fact that is Broadway Boulevard. So it's always good to spot check your data. Never take a GIS operation for granted. Check your results with a critical eye. And remember that you can also add the not found CSV file to QGIS Desktop and study that and try to see why the 4 records that didn't match and see if you can deduce why. Geocoding is often an iterative process where you make an initial run given your data and then you see what kind of errors may be preventing records from matching, correct those errors, and re-geocode. We got good results, but let's see what happens when we use the other geocoding option that comes with MMQGIS. So I'll go to MMQGIS, geocode, and geocode with the Google OpenStreetMap services. This tool uses the same geocoding engine that's used when you type an address into Google Maps. So it also requires an internet connection. So this tool is very similar. I'll browse for the address table. Google's geocoding engine requires a few more data elements. So in addition to street, it also asks for a city field, a state field, and a country field, which again, since they're named logically, the tool's picking up on automatically, but you can always click the drop down to change that if it's not picking the correct field. There's 2 services available here, Google Maps and OpenStreetMap. I'm going to use the Google Maps service. And again, I'll pick my output data file, and I'm going to call this Google addresses. And I will click the browse to specify the not found file for this operation. And I'll call this one Google not found. And once that's all set, I'll click OK. And the speed of this operation will depend on, in part, how fast your internet connection is. It may take longer than the street geocoding operation did. Okay, so the Google operation finishes. I'm going to make these points yellow. Again, bump up the size a little bit. And it looks like we got very different results with Google. It says it matched 203 out of 203 addresses. So let's investigate some of these. In fact, let's go into an area where we get different points being matched by each tool and see what's going on here. So I'll identify this one Google mapped point. This is supposed to be on Edith Boulevard. This is Edith right here. This street geocoded point is supposed to be on Bear Canyon Lane. Which it is. Let's also just right click on the Google layer and zoom to layer. It too seems to have mapped all the points to within the city, so that's a good sign. But it's interesting that the two tools seem to have come up with very different results, even though they both had to report a high degree of success. The points are in different places. All the points we've spot checked seem to be in the right place, but this is certainly an operation that's going to require some more data reconnaissance to validate the results and see which produced the better results. Since Google mapped all the layers, the Google not found.csv will be an empty text file. So once the data has been verified and you know which layer is the best, a product is usually required. In this case, a map is necessary to complete the lab. Data from several sources have been downloaded and included in your lab data folder. So the final task of this lab is to create a map deliverable. There's no video for this task since the map creation topic has been covered in previous labs. But in this lab, you learned how to geocode address data using the MMQGIS plugin. Geocoding is an important vector data creation process. There are many data organized by address, and mapping such data allows you to generate density maps, measure proximity of points, and perhaps even characterize the neighborhoods the points fall in with socioeconomic data from the census. Maps are often a part of a final product of a GIS project or analysis. Remember, GIS data are often free and there's a wealth of it on the internet. Just use it with caution and check the accuracy of the data if you can. One should explore data as much as possible before using it and endorsing it.